This session is about water treatment plant and various unit operations involved in water treatment process in context of drinking water supply. Water covers around 71% of Earth's surface. Out of the total water available, 97% is in oceans and is saline in nature, which makes it costly for treatment. The rest 3% is found in form of ice caps, glaciers, groundwater and surface water. Surface water is further distributed in lakes, swamps and rivers. Aim of water treatment is to remove color, odor, hardness, harmful microbes, turbidity, dissolved solids and make it suitable for various purposes like drinking, industrial use, etc. The various unit operations in process of water treatment includes screening, aeration, coagulation and flocculation, sedimentation, which is also known as settling or clarification, filtration, disinfection, softening, that is hardness removal, deferrization, that is iron removal, defluoridation, and water conditioning. It is not necessary that all these operation units are altogether used in water treatment plant. For example, the process of softening, deferrization, defluoridation, and water conditioning is generally not required in case of surface water like rivers. However, the same are must in case of underground water. Many different combinations of these operations can be chosen depending upon quality of raw water available, desired standard of water quality, comparative economics of alternate treatment steps applicable. Now let us take a look at schematic of a conventional water treatment plant and the units operations involved in it. The journey of water starts from the source itself, which can be a lake, river or any other water stream except seawater. Generally, water treatment plants are built near the water source itself. The first step in process of water treatment is screening. Screening is done to remove floating matter from water. Surface water contains large number of suspended particles like dried leaves, fallen twigs and debris that increases the unnecessary load on treatment plant units. These screens are of two types, namely coarse screen or bar screen, in which 25 mm bars are installed at 75 to 100 mm center to center distance to trap the large size particles. Then fine screen of size 3 to 10 mm to trap smaller size particles. Then comes the process of aeration. Aeration is necessary to promote exchange of gases between water and atmosphere. In water treatment, aeration is practiced for three purposes. First, to add oxygen to water for imparting freshness. Second, for expulsion of carbon dioxide, hydrogen sulfide and other volatile substances causing taste and odor. And third, to precipitate impurities like iron and manganese in certain forms. Next step is coagulation and flocculation. Coagulation describes the effect produced by addition of chemicals which are called coagulants to a colloidal dispersion, resulting in a particle destabilization. Operationally, this is achieved by addition of chemical and then rapid intense mixing for obtaining uniform dispersion of the chemical. Flocculation is the second stage of formation of settleable particles, also called flocks, from destabilized colloidal sized particles and is achieved by gentle and prolonged mixing. In simple words, the combination of rapid intense mixing and stirring, that is slow mixing, that produce aggregation of particles is designated by a single term, flocculation. The common coagulant used in water works practices are salts of aluminium such as filter alum, sodium aluminate and liquid alum, and iron salts such as ferrous sulfate, ferric chloride and chlorinated copper. Selection of aluminum or iron coagulants is largely decided by either type and its easy availability. The chemical coagulant is normally introduced at some point of high turbulence in water. Then comes sedimentation. Sedimentation is the separation from water by gravitational settling of suspended particles that are heavier than water. Sedimentation, also referred as settling or clarification, is used to remove readily settling sediments such as sand and silt, coagulated impurities such as color and turbidity, and precipitated impurities such as hardness and iron. When suspended solids are separated from water by action of natural forces alone, that is by gravitation, the operation is called plane sedimentation. But finely divided solids and colloidal particles which cannot be removed by plane sedimentation with commonly used detention period of few hours are converted into settleable flocks by coagulation and flocculation and subsequently settled in sedimentation tank. This is called sedimentation with coagulation. Then comes the process of filtration. Filtration is a process for separating suspended and colloidal impurities from water by passing through a porous medium or porous media. Filtration is employed to effectively remove turbidity, color, microorganisms, precipitated hardness from chemically softened waters, and precipitated iron and manganese from aerated waters. Filters can be classified according to various parameters. Based on direction of flow, They can be downflow, upflow, biflow, radial flow and horizontal flow filters. Based on filter media and beds, they can be granular medium filter, fabric and matte filters. The granular medium filter can be single medium, dual media and multimedia, which is generally trimedia. Sand, coal, crushed coconut shell, diatomaceous earth and powdered or granular activated carbon have been used as filter media. But sand filters have been most widely used as sand is widely available, cheap and effective in removing impurities. Based on driving force, filters can be categorized as gravity filters or pressure filters. Based on method of flow rate control, these are either constant rate or variable rate filters. And lastly, based on filtration rate, they can be slow or rapid filters. After going through all these processes, water thus obtained is aesthetically acceptable and economical to use. However, for utmost safety of water for drinking purpose, disinfection of water has to be done for killing of disease producing organisms, etc. Modern disinfection process includes use of physical methods such as thermal treatment and ultrasonic waves, chemicals such as chlorine and its compounds, bromine, iodine, ozone, etc. and thirdly, radiation. Most commonly used disinfectant in water treatment plants is chlorine and process is called chlorination. Depending upon the point at which chlorine is added, it can be either pre-chlorination, where chlorine is applied to water prior to any unit treatment process, and post-chlorination, where chlorine is applied to water before it enters the distribution system to maintain the required amount of free chlorine. Complete data are unavailable upon which to base recommendation of residual chlorine requirement to ensure destruction of waterborne diseases. However, in practice, 0.5 milligram per liter of free chlorine for 1 hour is sufficient to inactivate virus even in water that was originally polluted, and hence this may be adopted to make the water safe. When it comes to application of chlorine, it can be done by 3 methods. First is addition of weak solution prepared from bleaching powder. Second is addition of weak solution of chlorine prepared by electrolyzing a solution of brine. And third method is by addition of chlorine either in gaseous form or in form of solution made by dissolving gaseous chlorine in small auxiliary flow of water. After post-chlorination, treated water is stored in underground tanks from where it is supplied further to distribution network. However, before supplying the treated water to end consumer, it is to be tested for its potability. For this purpose, Bureau of Indian Standard gives standards under IS code 105002012, which prescribes the requirement and methods of sampling and test for drinking water. The requirement and parameters specified in the standard are grouped in 6 categories. First is organoleptic and physical parameters such as pH value, turbidity, total dissolved solids, commonly known as TDS. Second is general parameters concerning substance undesirable in excessive amounts such as calcium, iron, fluoride, total alkalinity, total hardness, etc. Third is parameters for toxic substances such as cadmium, lead, mercury, total arsenic, etc. Fourth is parameters for radioactive substances such as alpha emitters and beta emitters. Fifth is pesticide residue limits and test methods such as DDT, endosulfan, etc. And sixth category is bacteriological requirements for E. coli and total coliform bacteria. Drinking water shall comply with the acceptable limit of these parameters as specified in details in the IS code, and the testing shall be conducted by a recognized laboratory using internationally established test methods. Hope you find this video informative. Thanks for watching and stay safe.